Hello everyone, welcome to your 10-4 lesson on inscribed angles. Our learning target for this lesson, we will be able to use the relationships between angles and arcs in circles to find their measures. We will identify and apply relationships between the measures of inscribed angles, arcs, and central angles, and we will also identify and apply the relationships between an angle formed by a chord and a tangent to its intercepted arc. All right, to start off, let's explore a little bit here. First, let's list some things we know or can find about this diagram. It says 7 things, but I think we'll be able to come up with a couple more than that. So first, we know that AC is the diameter. If AC is a diameter, that means we have some radii as well. We've got TA as a radius, TC as a radius, and TB, I'm going to say our radii, plural, but we've got those radii in there. We can see that angle ATB right here is 52 degrees. That's a central angle. If the central angle is 52 degrees, that means that arc AB has the same measure, 52 degrees. Let's see, what else can we say? Because of this diameter right here, if this is 52 degrees, this angle right next to it that forms a linear pair will be supplementary. So if we take 180 minus 52, we get angle BTC to be 128. So this is this angle right in here, 128. Well, and that's a central angle. If BTC is 128 degrees, that means arc BC is 128 degrees. Let's see. We've got segment BC right here. That's a chord. So we know that BC is a chord. Let's see, what else could we say? Do you guys see this triangle TBC? So because triangle TBC has two sides that are radii, that are a radius of the circle, and we know that all radii are congruent, we can say that triangle TBC is isosceles. When you have an isosceles triangle, you have congruent angles. So this angle here at B and this angle here at C are congruent. So angle TBC is congruent to angle TCB. Because in this triangle that's isosceles, one angle is 128 degrees, the other two angles are congruent. So if we take 180, the full triangle, subtract out 128, and divide that by 2, we can figure out that both of these angles are 26 degrees. So we know that angle TBC is 26 degrees and angle TCB is 26 degrees. All right, how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, we were on a roll. We found 11 things. All right, so now that we have worked through some things, how is angle ACB related to angle ATB? Well, angle ACB is this angle right here, ACB, this angle at C, which is the same angle as TCB, we just are using A to C to B, that is this 26 degree angle. And then angle ATB, we said right here, is 52. Well, what's the relationship between 26 and 52? If we take the 26 and double it, we get 52. So we can conclude that angle ATB is equal to 2 times angle ACB. This 52 degrees is equal to 2 times the 26 degrees. Well, angle ATB is a central angle, 52. Remember how we said that arc AC is 52 degrees? So we can replace that. Another statement we could say is that arc AC is equal to, that 52 degrees is equal to 2 times the angle ACB. Okay, what are we talking about, right? This is going to lead us into our 10.8 theorem, where we get to talk about inscribed angles. So let's put a definition in here. An inscribed angle it's an angle with the vertex on the circle. I'm going to capitalize the word on. So on the circle. The vertex is on the circle. And its sides, so the sides that are forming the angle are chords of the circle. All right, when you have an inscribed angle, the inscribed angle is equal to half of the intercepted arc, or 1/2 times the intercepted arc. That's the relationship between an inscribed angle and an intercepted arc. All right, so let's look at 3 different cases of what this could possibly look like. We're going to put center C in each circle. Our first case is if we have, we're going to draw a line, we're going to draw on the diameter essentially, and then let's draw over here, and here we have these 3 points. This is R, S is the vertex, and T. So in case 1, the center of the circle is on one side of the angle. So you can see here's the center of the circle. Here are the 2 sides of the angle. The center is on one side of the angle. Another way that this could look is, what if we draw our angle like this, where this is R, S, and T. In this example, the center of the circle is inside the angle. And then the last way that this could play out is maybe that center of the circle is outside of your angle. So here's the R, S is the vertex, and T. So the center could be outside the angle. All right, for all 3 cases, the measure of angle RST, so RST whether it's right here, RST where it's right here where the center is on the inside, or RST where the center is outside the angle, the measure of angle RST will be equal to 1/2 times its intercepted arc. And the arc it intercepts is the arc that it kind of, if you follow your angle out, the arc it creates, or that it intercepts of the circle, it's always equal to half of arc RT. So that's the relationship between an inscribed angle, an angle whose vertex is on the circle, and the intercepted arc. It is equal to half of the arc measure.